Okay. Well, thank you all for joining us on our third Thursday event. Actually, for the last week, since last Thursday, our center has been really distracted. And I want to begin by first expressing our deepest condolences and offering our prayers for the many, many people in Hawaii who've been impacted by the fires on Maui. And again, I think we all have to pull together on this and continue to work to try to support our family and friends and colleagues and other members of our community that have been impacted by this disaster. And part of it is also recognizing that we have to balance this between the emergency and crisis and disaster that's going on and ongoing other work, other things that we have to do to continue the progress. And so the second thing I wanted to say is I know many of you on this call, on this staff, on our staff and part of the NDPTC family have really come together to try to work to help and support the efforts here. And so I want to begin by expressing my profound gratification, gratitude to all of you for your continued work on this. This topic on hydrogen is very, very important to us. And I think that there's lots of work that we're very interested in. And I feel really fortunate that we can think about many of the issues and to bring together really people who've been at the leading edge, at the front edge of this topic. And so what I'm going to do right now is hand it over to Lydia to introduce our speakers and our topic for today. But again, thank you all for joining us, and thank you all for all the good work that you do.
Thank you, Carl. I'm sure a lot of folks are interested in what's happening in Maui right now and across Hawaii. So for today's third Thursday, we have a couple of exciting speakers. And our topic for today is advancing toward a hydrogen-powered society. Our first speaker is going to be Mr. Mitch Ewan from Hawaii Natural Energy Institute at the University of Hawaii at Manoa. He's the Hydrogen Systems Program Manager, and he's going to kick us off. And his presentation is going to lead into Dr. Ganesh, I knew I was going to do this, Arumugam. Did I do that? Was it close? He's the Senior Materials Engineer at Oceanit. So Mitch, anytime you're ready, we're ready for you.
Okay, I'll kick it off. So basically, I'm going to be talking about two main things. First of all, HNEI's hydrogen infrastructure for public transportation program. That's how I choose to characterize it. And secondly, firstly, I want to lead off with a little systems engineering diagram, kind of describing what an hydrogen energy system looks like generically. And so that you can see all the various pieces and how the pieces of the puzzle fit in. So I'm assuming my second slide just came up. So first of all, if you start on the upper left-hand side, we start off with energy sources. And by that, I mean, raw energy or primary energy sources like geothermal, wind, solar, biomass, hydro, and water, which are all resources we have here in Hawaii. And then we have to produce hydrogen using these resources. So the the main production technologies are, first of all, electrolysis, which produces green hydrogen, assuming the electricity powering the electrolyzer is, quote, green. And then there are thermal processes like pyrolysis, steam methane reforming. And there's also, you can still reform natural gas if you can capture the carbon dioxide that's given off, and that's carbon capture, storage, and usage. That's a little CCSU under that system element. Then we have to store the hydrogen if we're not going to use it right away. So the main ones are compressed, like you have a compressor and compress it into a gas cylinder at high pressure. A liquid, which I see is going to evolve, but I think that's going to be our major storage medium going forward to get the quantities of storage that we need. And then metal hydrides, which is like a sponge. It's a low pressure and it basically absorbs the hydrogen in its materials. Next, you have to distribute it. Dispensers, which are just like your gasoline dispensers at a gas station. You'll see some pictures of that. You can transport it from where it's made to where it's used using hydrogen transport trailers, which you'll see some pictures and stuff we have, and pipelines, which Ganesh is going to be talking to us about, which is actually the most economic way to distribute it once you have the infrastructure in place. And then finally, we get to all the end uses, transportation, which is going to be the major focus of what we're doing at HNEI. But then you have industrial, like using hydrogen for refining crude oil, and then various power outputs like fuel cells, gas turbines, whatever. So that's the the hydrogen energy system, and this applies to whether you're in Hawaii or on the mainland. So you can find all these elements in any kind of a hydrogen system. So here's the big question: why hydrogen in Hawaii? First of all, we want to displace, we want to decarbonize, we want to displace fossil fuels for transportation. It provides long endurance energy storage, and used in a fuel cell. The only byproduct is pure water, so it's a perfect system. If you're using electrolysis, you split the water into hydrogen and oxygen, you use it, and it returns to water. So it doesn't get any better than that. We can produce it in Hawaii, so we don't have to import it using our local renewable energy resources. We can talk about that. And it retains billions of dollars in the Hawaii economy, which is good, obviously, for the economy and good for jobs, and provides energy security for Hawaii. You don't have to worry about whether that ship full of oil is going to show up if there's a war like we're having in Ukraine, etc. There's no wars to interrupt the supply chain because we can make it here, made in Hawaii, and we'll never, ever run out of hydrogen. If you look out, your window at the ocean, that's all an ocean of hydrogen. So here's the question: why are we using hydrogen for mobility? First of all, it's lighter weight than batteries. So if you look at what car companies are doing, they're always trying to get the weight out of the car, but then we load a ton of batteries into it, which you carry, you're lugging a ton of batteries wherever that car goes. Whereas you have much lighter weight using a hydrogen system. It enables zero emissions in all kinds of transportation, aviation, and marine shipping. You can rapidly refuel your vehicle, like you can refill a light-duty car, like a car, in under 5 minutes. And I have some buses that we can refuel those in about 14, 15 minutes. And NREL and other people, they're looking at refueling major trucks in like 5 minutes. Much longer vehicle range. I saw an article just came out. They got 634 kilometers. It was a European thing. Just the other day on one load for a small light duty vehicle. And unlike batteries, there's no self-discharge. So I have hydrogen storage that's been sitting around for 10 years. And it's still there, and it still holds its pressure. So here are the sources. We talked about them in that first slide. But here for Hawaii, my favorite one is geothermal, and that's a picture at the upper left there with the geothermal. I took that picture about 15 years ago. But we have wind, solar, biomass. We have a little bit of hydro. We have all of that. And of course, on the right are all the things we want to get away from. Is all the fossil fuels, which are termed traditional sources. So hydrogen does not occur naturally, although we're starting to see some suspicions that might be happening. But so you have to break a molecular bond between the hydrogen and whatever the host is. Normally it's carbon, but it could be nitrogen. So that requires energy, either electricity or heat. And we have to, people are working very, very hard at improving the efficiencies of those transition technologies. So we have to start looking at hydrogen at scale. And by at scale, I mean really big. So if you look at that electrolyzer module, you can see it's as big around as tall as a human being is. And that's a 2 megawatt unit. And it produces a ton of hydrogen per day. That's over a 24-hour period. But that's where we need to go if we're going to decarbonize and we're going to hydrogenize the Hawaii economy. So it's not little desktop stuff. This is really big stuff. And we need low-cost electricity, like geothermal. Grid electricity just won't work. I can't afford to pay 30, 40 cents a kilowatt hour for my electricity. And of course, the environmental impact all depends on what the primary energy source is to make that electricity. We don't have to worry about the vehicles. That problem has been solved. You can buy any kind of a hydrogen vehicle these days. Here's a whole bunch of them here. So here's, I'm going to talk a little bit about, I've termed it the HNEI Hydrogen Hub Project. You've probably seen a lot of hubs lately because of the Department of Energy Hub program, but we came up with this 5 years ago. So, and the whole objective is to introduce public transportation using hydrogen and to de-risk it from the counties who are operating these buses so that they don't have to go out and put together a project themselves and get money and install it. We did it all, and then we can just demonstrate it to them. And we make all the mistakes so that they don't make mistakes. And that's the best way to introduce it, both to the public and to the mass transit agencies. And that's our first bus that's been deployed on the Big Island. It's a 19-passenger bus that HNEI purchased using barrel tax money, and we gifted it to the mass transit agency on the county of Hawaii on the Big Island. So the other component is we have to develop infrastructure. It's infrastructure, stupid. That's what we need. That's what's keeping hydrogen from vehicles from proliferating. And so this project is the first hydrogen, one of the first hydrogen infrastructures in Hawaii, and it's essential to enable fuel cell electric vehicles to be used. Industry will supply the vehicles, but they need to know, where can I fill my car or my truck? And that's what we have to provide, or we, the royal we, the state and industry. And industry, once private industry sees it can make money from this, they'll start paying for it. But right now, it's all government funding and government grants. And so what we want to do is we want to support these early users of hydrogen, like buses, which use a lot of hydrogen, like 20 to 30 kilograms per fill. So we can build up the demand for hydrogen to be able to make that conversion from public stations over to private stations, i.e., so the guy who has a gas station can start making money at it. So the plan is to focus on fleet vehicles, once again, bus fleets in our case, which have central fueling. Therefore, they generate a large hydrogen demand, 30 to 40 kilograms per bus, I told that. And there's a public benefit to this because, it's public transportation, and we're using taxpayer dollars to support the public transportation needs. So it gives the public an opportunity to become familiar with hydrogen. Anybody can get on the hydrogen bus we have on the Big Island and have a ride in the hydrogen bus and see what it's like. Whereas if it's a private individual, you're not going to invite people necessarily to have a ride in your car. So that's all part of the strategy of the Hydrogen Hub project. So hit it again. Here's our hub. It's demonstrating the hydrogen infrastructure. It includes production, storage, dispensing, all the elements in that diagram I showed you. Plus, we have a fleet of 3 hydrogen transport trailers. You know, we work closely with the County of Hawaii agencies, mass transit, planning and permitting, county, first responders, and the research and development organization. And like I said, we purchased the first fuel cell electric bus for public transportation in the state of Hawaii and donated it to the county. So here's a picture of our hydrogen station at Nelha. That's the entrance. And on the left, you see that bus parked inside there. And that's where we have all our infrastructure. And it's located, if you go to Nelha, it's right down at the bottom of their campus. And you can't miss it, it's on the left. So here's a 3D rendering of it. I'll start off with the standard shipping container. Everybody's got a shipping container in their project, so we're no different. So in that 40-foot shipping container, we have the electrolyzer to make the hydrogen. On the left, we have the compressor, and then we've got the the control systems in the electrical room on the right. The power supplies are that big concrete wall right at the front. I'm not sure. I guess you can see my mouse here with the way we have that. So we had to build this, and there's separation distances between all of these for safety. Chillers for the compressor and for the electrolyzer. This is where the inefficiencies are. We reject a lot of heat. And here are my renderings of my hydrogen trailers. And everything is undergrounded here. Under this concrete pad, which has got a lot of rebar in it, there's a whole array of hydrogen pipes, sensor systems, and thank God it all worked when we started it up, because if it hadn't, we would have had to jackhammer that thing up and make it work. Oh, sorry, just this bottom one. This shows you what the compressor looks like. That's just the electrolyzer, and then we have our electrolyzer room here, or our electrical room. So that's the real deal. This is what it looks like in real life. And you can see it looks a lot like the 3D rendering, funnily enough. So this is where the dispenser is up here. The bus comes in through a gate here and then exits through this 30-foot gate here. And that's how the flow works. And we have our tube trailers parked under here. And like I said, the hydrogen flows under the concrete pad through the dispensing system. This is a driver's view coming into the station. So it looks just like a normal gas station dispenser on the left. And that's what they see. And this is totally automated. There are no people operating this. The only human interface is connecting the nozzle to the bus and disconnecting it at the end when it's done. So that's for safety, and also, save money. People cost money. So here are some of the advantages of fuel cell bus. It's a very quiet ride. You hear a lot more rattles because they don't have the diesel engine masking it. No diesel fumes, beautiful air conditioning, always on. You don't have to shut it down for anti-idling. So the bus stays cool. The drivers like it and the passengers like that. Really good performance. You can almost, screech the tires on it. There's so much torque. And there's the potential, keyword for lower O&M costs, but we need low-cost hydrogen to make that happen. Right now, I'm paying grid electricity costs, and that's not viable. So we're also leveraging our buses. We put in a power export unit, so each bus can operate as a mobile power unit, and we have 110 kilowatts of power for 32 hours. And 110, 220 volt AC, 60 hertz, standalone, and we can refill that hydrogen tank in 15 minutes. So, civil defense really like this idea. So all your buses can then be used in an emergency. So it helps justify the cost of the system because you're saving lives, saving infrastructure. Wouldn't it have been nice to have this over in Maui right now? So just a couple of major accomplishments. We won $14 million worth of low-no emission grant funding this past in 2022. It'll buy 6 hydrogen buses, some infrastructure and workforce development. We completed 1,800 miles of testing on Oahu before we shipped it over to the Big Island. We've commissioned that first fuel cell bus. We've done first responder training and bus operator training. And we're currently upgrading 2 additional buses with a 90 kilowatt fuel cell as opposed to the 40 kilowatt fuel cell. We need that extra power because of the topography over there. So those buses, the 90 kilowatt buses, will be able to go up pretty steep grades. Here are our friends and partners. Obviously, the state of Hawaii's got money in this. The Department of Energy, ONR, Office of Naval Research, has a lot of money in it. NELHA has done a lot of cost share and support. And a big shout out to US Hybrid, who is our system integrator and helps maintain the buses. And that's it. So if you need to get contacted me, this is where I'm at. Aloha. So I can stop sharing my screen now. And there we go.
Thanks so much, Mitch. That's super informative. Ganesh, are you able to test it?
Yeah, I'm going to start my screen share. Give me yes. Are you able to see it?
Yeah, looks good.
Yep.
Right. All right. Good afternoon, everyone. Thank you, NDPTC and team, for inviting Oceanit and me to present our work in the hydrogen space. Thanks, Mitch, for setting up the background for hydrogen work in Hawaii. I want to talk a little bit different from how Mitch went on. Our focus primarily right now is in the hydrogen transmission. I'll get to there in just a bit. Before that, a quick introduction. My name is Ganesh Kumar Arumugam. I'm a senior materials engineer with Oceanit. I've been with the company for almost 14 years. My background is in electrochemical engineering, materials science, and nanotechnology. And I've been involved in developing materials and coatings technology for a variety of applications. Quick overview of who we are. Oceanit is a Hawaii-based science and technology company involved in developing solutions for a variety of industry, anything from energy, defense, aerospace, biomedical, life sciences, information system. Our headquarters is in Honolulu, Hawaii, and we also have offices. We have facilities in Houston for particularly scaling up and field deployment in the energy industry, and also satellite offices in DC and California. And a lot of our scientists and engineers work on developing new solutions for these industries. We work with different customers, government, private, state, on every level. And our agenda is to take the technology to market. We call it as mine to market. And we've been successful in moving a number of different technology to market. The bottom right on the slide shows some of the technologies that are currently out there that is either venture funded or licensed or commercialized through Oceanit. With that introduction, I will jump into the discussion. Hydrogen. Hydrogen has been a topic of interest for a number of years, but it had lacked traction. But recent interest towards decarbonization has picked up more interest on utilizing hydrogen. And there is a stronger push from the federal government in terms of reducing the carbon emissions and getting down to net zero greenhouse gas by 2050. That is sort of the driver for moving in the direction of hydrogen. And there is, as Mitch pointed out, there are multiple ways to get to hydrogen, but it's still a very early stage in terms of hydrogen utilization. And there is an aggressive push to make it happen. This is sort of an overview of everything that's going around or available for hydrogen. Hydrogen is primarily produced from methane through steam methane reformation process. That is basically from the oil and gas drilling. The methane that comes out is being processed into hydrogen, and that is the main source of hydrogen. There are other greener sources of hydrogen using photovoltaic or wind energy or using green energies to produce hydrogen. Those are still in early stage. And a lot of them requires infrastructure to move the hydrogen that is being produced and take it all the way to the customer. And the customer could be the hydrogen fuel cells, or it could be for fuel cells at home, or for using hydrogen as a fuel to heating, or even energy generation by the power sector. A lot of them can utilize hydrogen, but unfortunately, it is not readily available for them to utilize. So the big bottleneck in that is the existing infrastructure is not prepared for hydrogen usage. And that is where we're trying to address one of the problems in that space. In terms of hydrogen production is scattered around oil refining areas because of the source primarily coming from methane. Hawaii has some hydrogen production capability here, but on a very small scale. In supply of hydrogen is a major challenge because it's mostly restricted towards areas where it is being produced. The blue lines on the US map shows the pipeline network that is available, but that is not used currently for hydrogen transportation. It's usually moved through rails or containers, or in a much more expensive way to get hydrogen to the end customer. And in order for hydrogen to be a candidate for decarbonization, there are a number of things that needs to happen. From the production standpoint, you need to reduce the cost of hydrogen production. There's a lot of opportunities out there in using renewables, energy, nuclear energy, and fossil fuel is one. And the DOE has set a goal of producing 1 kilogram of hydrogen for $1 within 1 decade. That's currently called as the hydrogen shot. A lot of companies working in that, and that actually helps to get hydrogen into a variety of industry outside of oil and gas and refining. One pathway is to blend hydrogen with natural gas, and that can be pumped through the natural gas pipeline, and that can get to the customer. They can use it for energy generation or any application where they would use it and help reduce the carbon emission. And our work is primarily on the blending of hydrogen with the natural gas. In terms of the market breakdown, where the hydrogen that is being produced is currently used, the transportation is only 10% of hydrogen getting used in that sector. Majority of them, it goes to petroleum refining, ammonia production, or methane production, or any kind of chemical refining process. That's where the hydrogen is being utilized. In order for more utilization of hydrogen, the infrastructure and also the vehicles and everything needs to be improved to accept the hydrogen and utilize it. The production market is still in the early stages. The hydrogen is not produced as much as oil and gas, and it is expected to grow in the next 20 to 30 years. Right now, we're looking at 65 million tons of hydrogen produced, and it is being targeted to get to 400 million tons by 2050. That would actually help in terms of moving towards a net zero carbon emission. There are a lot of drivers that is causing it. I don't want to go into too much detail in all of these companies and industries playing a role, but a lot of interest from the governments and public sector and private companies focusing on finding a way to utilize hydrogen, either in the form of fuel cell or either using hydrogen in their energy portfolio to reduce the carbon emission. And hydrogen shot from the DOE is one particular program that is addressing to the utilization of hydrogen. And there are definitely a lot of challenges in getting there. Even though we talk about a lot of hydrogen, the hydrogen transportation particularly is not fully developed. There are alternatives to hydrogen that are being currently used, and that is actually a barrier for getting the hydrogen to the customer. It could be natural gas, it could be the electric vehicles. Hydrogen blending into the natural gas is still considered an early stage. There are a lot of other alternatives such as ammonia or liquid hydrogen being stored for long-term transportation. And there is also other alternative mechanism people are looking into in terms of utilizing hydrogen. And in terms of the hydrogen work at Oceanit, we've been working on hydrogen for almost like 12, 13 years, and we worked on a number of different areas within the hydrogen. Right now, our focus is around production and transportation. We have a technology called Halo that we are currently developing that utilizes waste feedstock. It could be produced water from oil and gas exploration, or it could be a biomass waste that could be fed into the Halo equipment that can actually convert that into hydrogen. And it is a feed agnostic device, meaning there is no, it can take any kind of feed that is available and that can convert that into hydrogen. Another aspect is the transportation part that is a critical in terms of utilizing the hydrogen coming from the oil and gas infrastructure. What we are working is the technology for transforming the existing natural gas pipeline to allow for blending. There are some challenges in utilizing that. I will talk about in the next few slides. And while you blend hydrogen or use hydrogen, there are necessity for monitoring the hydrogen, monitoring the leaks, or identifying the leaks. And we have something called HYDEOS, which we developed through DOE funding for gas sensing using an optical sensor. These are also in very early stage. Prior to these efforts, we have worked on hydrogen storage. As Mitch was pointing out, solid state hydrogen storage is a big interest for the automobile sector, and also the fuel cell catalysts that are necessary to reduce the cost of fuel cell that is on the existing fuel cell vehicles. We worked on nano catalysts that helps in efficiently producing energy from hydrogen as a source at a very lower loading compared to commercial ones. These are some of the areas that we have worked. I just want to focus only specifically on the hydropel, which is an active effort that we're pursuing right now. So as I pointed out, the transportation of hydrogen is still a big problem for the industry. One particular solution that is attracted the industry is to utilize pipeline for transportation of hydrogen, usually in the form of blending. US has a vast network of pipeline, over 1 million miles of pipeline available. But unfortunately, these pipelines are not designed for carrying hydrogen. There are some inherent challenges in doing that. In only 1,600 miles of pipeline is currently available in the US for carrying exclusively hydrogen. A lot of people have been debating on how much hydrogen you can put into the natural gas. The golden number people are targeting is up to 20% of hydrogen blending with methane. That way you can maintain the energy output of the methane gas, since hydrogen is much more lighter in terms of mass and density. And the method for the choosing pipeline is because pipeline offers to be the most economical way to move gas from point A to point B. It is almost 4 times cheaper than trucking. One particular problem with the existing infrastructure is a lot of the pipeline material, the high strength pipeline steel is potentially can get potentially embrittle, which means it can get brittle over a period of time, and it can cause cracking or fractures, and it can eventually rupture under high pressure. And that is a major concern for putting hydrogen in the existing pipeline. And if we have to build a new pipeline, the cost of building is enormous. It used to be 1.8 million in early 2000. Right now, you're looking at almost 4.5 million per mile. These are like 36-inch pipeline. And there is a immediate need and also economical need for utilizing the existing pipeline for transporting hydrogen, but there needs to be a technology that would enable a safe transport of hydrogen in the pipeline without it getting embrittled over a period of time. And the solution that we're developing is Hydropel, which is a surface treatment technology that we can apply to existing as well as newer pipeline that will be built. This is a surface treatment process using a industry accepted in situ technique that can actually apply the coating on the existing pipeline without removing any of the component. In the right-hand side, top picture shows some of the schematic of our surface treatment concept. What we have here is a pipe section that is cut open to show a untreated section where you have significant corrosion on steel, and a Hydropel treated section showing the different layers and also the treated part showing there is no corrosion, and also there is the potential for eliminating embrittlement. We have done extensive testing on the laboratory side in terms of evaluating our performance under hydrogen and methane environment. And we're pretty confident in terms of reducing the embrittlement, and in some cases it can eliminate. And we're still continuing the testing of the Hydropel technology. The unique aspect of this is use the existing tools available within the industry and can start applying the Hydropel surface treatment on existing pipeline. And while we're developing the technology, we also looked at the economic impact, what it would have if we have to transform the existing pipeline versus building a newer pipeline. The chart on the right-hand side shows a comparison between the cost of new pipeline versus refurbishing the existing pipeline with Hydropel. And these are estimated for 100 miles, 1,000 miles, and 10,000 miles. And over longer distances, when operating the pipeline for longer duration, you're looking at a significant savings. And if you have to transform the existing pipeline network, and you're looking at trillions of dollars in terms of infrastructure money, instead refurbishing the existing pipeline using a surface treatment can enable a much more accelerated transformation of hydrogen usage. In terms of the Hawaii, we've been collaborating with Hawaii Gas in terms of understanding how the pipeline works. And due to the nature of the gas that you're getting in Hawaii, you could have up to 15% hydrogen in the natural gas blend. This is part of the process as the Hawaii Gas is producing. So, and Hawaii Gas also maintains over 1,000 miles of pipeline network within this Oahu. And we're collaborating with them to conduct long-term studies on this natural gas hydrogen blend in their pipeline. And there is also potential for looking at other impact of hydrogen and natural gas on appliances. With that, I want to wrap it up. What we have is a new surface treatment technology that is developed for transforming existing natural gas pipeline to enable hydrogen blending without impacting the steel surface from the hydrogen embrittlement problems that are common. We have a industry accepted surface treatment approach to apply this technology, and also looked at the cost effectiveness of the Hydropel versus new pipeline. And the material and the technology is very scalable, and we're looking at a rapid field deployment in the future. With that, I want to wrap it up, and thank you for your time. I'll be happy to answer any questions.
I think Carl had a question for me.
Yeah, first, thank you both for really excellent, informative presentations. I wanted to quickly update some of the things that we are doing as well too. As I think many of you know, we're part of a team to test and evaluate the first hydrogen fuel cell train built by Stadler Rail to be implemented in San Bernardino, California to Redlands, California. They are delivering the train set later this month to Pueblo, Colorado. for testing with Stadler and ENSCO and then the Transportation Technology Center, which is part of the Federal Railway Administration and FTA as a test site. They are trying to set up a facility for storage, refueling, dispensing, potentially even generation on site. Initially, I think this will be supported by trucking the hydrogen in and dispensing it from that system. But we want to build a longer term test facility for testing these vehicles, train sets, and new developments. And so that's part of it. This is linked to the work that we do at the center, because we train first responders and emergency managers, and then also planners and others involved in permitting and regulating and ensuring the safety. So I am going to turn to Mitch and ask about the training for first responders and emergency managers and others that have to deal with these incidents. But it's related to some of the larger issues and concerns that we have with building a hydrogen economy, building a hydrogen production and distribution system. And my question for Ganesh, which I think again is really important, is how can we build upon the existing infrastructure here in Hawaii, and how that can be used to support not just the transportation industry, but I think that there are other applications, as has been pointed out. So with that, can I first turn it over to Mitch to talk a little bit about the training?
Sure. Yeah, happy to talk about that. Basically, when we started the project, there was no training available. And we tried to work with Hawaii Community College, but there's a lot of, I don't want to call it barriers, but speed bumps in setting up a training program. Not the least of which is finding, your courseware or your curriculum, getting it approved, and then actually finding people who can give the course, trainers. And that seems to, those seem to be like really difficult speed bumps to get over right now. But meanwhile, my buses were coming down the line and we had to get people trained up. So bottom line is taking the old Navy approach, is we did it ourselves. So first of all, on the first responder training, which is the U.S. Department of Energy has an excellent website where they have a first responder training courses. It's an online course. It takes about an hour, almost 2 hours to work your way through it. And the advantage is that, you take an exam at the end and you get qualified. They give you a certificate of completion. And most first responders across the country are using this. So it gives you some kind of a qualification that's available. And then we did our own, from the point of view of familiarizing the first responders with our actual system, we actually conducted in-person first responder training at Nelha, and then took them out and actually showed them all the equipment. So we trained up about 35 to 40 firefighters, a lot of senior people, even the fire chief himself was one of our students. And they seemed to like the course. And the other advantage I had is I had like some very senior inspectors from the first responders inspecting my station at the same time while they're doing the familiarization. So that worked really well. But we have to work on that. That kind of training is kind of like an orphan out there, and we need to do a better job. From the point of view of the drivers, we also produced our own hydrogen safety course, and with Roberts. Roberts is a fantastic company, and all the drivers for the buses on the Big Island are Roberts drivers. And so they have a very good training system. So we train them up, and And then they also use the online course with their drivers. They have a training room where they could pull it up, and then the drivers could take their own training. So that's kind of the training we did, is basically hands-on practical stuff using the resources that are available.
Yeah, that's really great. You know, we went to Foothills, which has one of the largest hydrogen fuel cell bus operations in the country as well too. And they have promised to share their training materials as well too. And so there may be other ways that we can you know, connect. And this is the work that Lydia and others on our team really manage in terms of the development and implementation and resourcing of training where there is a need and demand for that. So, so we will be following up with you on this as I think we've initially discussed. Okay. Can I turn to Ganesh and ask Ganesh to talk a little bit more about the infrastructure? We've had a long history of kind of blending. You know, I mean, I think are we one of the only places that does that still in you know, blending like with cooking gas?
Hawaii has a very unique infrastructure, and as you probably know, there is hydrogen in the natural gas that is coming through that is part of the synthesis process. So the uniqueness here is the pipelines. In terms of the pipeline, the age of the pipeline matters in terms of how hydrogen impacts them. The newer high strength steel pipeline that are built in the mainland after 1980s or 1990s, and those have a higher chance of getting embrittled or getting damaged with respect to hydrogen. The network that we have in Hawaii is much more older and uses a very particular grade of steel that is not prone for hydrogen damage. And that is one of the reasons we've been able to successfully run it. And that actually has created a lot of interest for people coming into Hawaii to understand impact of hydrogen when you have it in a pipeline. And there's been a conversation that has taken us to a lot of different places, met a lot of different people, try to use Hawaii as a test bed, and a lot of people are doing that and figure out what needs to be addressed if hydrogen gets into the natural gas stream and natural gas infrastructure.
Right. That's really interesting too. And also in your presentation, you talked about the different potential feedstocks, you know, these digester systems and other, you know, we don't have, you know, oil and gas here, or so part of what I'm interested into, other than, you know, bringing in the natural gas and from outside sources, you know, are there ways that we can build off of, you know, some of these other renewable or locally sourced feedstocks for this? Does that make sense?
Actually, there is, for hydrogen, one particular source is not going to be sufficient. One methodology may not help in terms of decarbonizing or reducing the emission. I think we need to look at all different options. It could be the fuel cell, it could be using hydrogen in gas turbine, it could be hydrogen for hydrogen-based appliances in our regular cooking. And it could be using electrolyzer to produce hydrogen, use the photovoltaic or wind energy that is abundantly available in Hawaii, and utilize multiple energy sources to produce hydrogen. And one of the technologies that I pointed out is the HALO technology is in a very early stage, but the concept there is a unique system that can intake any kind of feedstock. It could be waste product, it could be biomass, it could be in some cases wastewater, and extract hydrogen through our process, and then utilize that hydrogen for potential application.
Yeah, this is really informative, and one of the things that I wanted to also talk about is the difference between combustion of hydrogen or blends versus use of fuel cells and the challenges of both approaches. And then actually with fuel cells, as we're finding with the train project, it is still about those heavy batteries as well. So I don't know if you want to comment on that, and then I would turn it over to Mitch before I open it up for others to ask. I could just dominate this whole talk today, but I want to open it up to others. So Ganesh, could you comment?
Yeah, in terms of fuel cell, you're looking at pretty much neat hydrogen, 100% hydrogen on one electrode, and then you have oxygen or air flowing through it. And let's say if you have natural gas hydrogen blends in the pipeline, and if you want to use that, then you may have to separate the hydrogen from that and then feed into the fuel cell system. That is one possibility. People always look for the electrolyzer type of solution that can instantly produce hydrogen. Because you electrolyze water, you're getting hydrogen, you should get it compressed and then put it in a gas tank or feed it to a fuel cell unit. In terms of combustion, hydrogen blending in methane can be combusted. Like people have started using in turbines and stuff with the hydrogen natural gas blends. And there are people looking at pure hydrogen combustion in engines. That is also a possibility. The equipments or components, people are still going through the evaluation. Like a lot of them are not readily available. These are pretty new, and it probably needs to get qualified or approved for a lot of this usage. And blending hydrogen with methane comes with a caveat. You may reduce the overall energy output of methane because hydrogen is less denser. So the amount of energy you're going to get per volume is going to be lower versus methane. So there may be a cap in some cases how much blend you can use. And there could also be cases where you want to burn methane and compensate the carbon emission to achieve carbon credits. There are companies that would be interested to do that.
Great. Yeah, thank you. Mitch?
Yeah, well, I'm a fuel cell guy, so I don't like combustion per se. What people ignore on the combustion side, so I'm going to sound like I'm a real negatory here. Apologize for that, but is NOx, because combustion is hot and you're burning and you're combining it with air, which is 80% nitrogen, and so you're producing a lot of NOx or NOx. And that's a greenhouse gas, excuse me. Whereas the beauty of a fuel cell, it's a low temperature device, and you're basically not producing any NOx. The only thing you're producing is pure water again. So that's where I come from. That's my feeling about it. I think there's going to be obviously a transition. I mean, so you have to work your way through a transition period, but eventually I think we have to look at the holy grail that we're trying to get to, and that's to have a totally electrochemical system, doesn't make any noise and doesn't make NOx, and it's pretty efficient. I saw one of the questions here was round trip efficiency. I can talk about that a little bit if you want.
Sure. I guess there was one point I wanted to add, which was that when we have met also with bus and transit providers, and we actually went to New Flyer as well too, the largest producer of fuel cell buses in the U.S., I believe. And one of the things is the difference between tailpipe emissions, which are low,
Right.
versus the production of the fuel cells, the production of the batteries, the disposal of the batteries, and all those other requirements associated with that, which we're still trying to better understand and manage. Yeah, so there were other questions. Did you?
There were a few questions. In the interest of time, short answers, please. And we'll get to a couple of them. If you have a question in the chat that we don't get to, I will send them to our presenters and include that in our email out to everybody. The first question we got was, what are some of the main safety issues?
So in pipeline, if you're dealing with methane, blending hydrogen is to make it a flammable gas, and you have to take all the precautions that is there for utilizing a flammable gas. And obviously there are some specific concern when you try to pressurize it and then use that. I think that needs to be more on an industrial scale, on a domestic scale. If you have blended hydrogen, natural gas, you're looking at pretty much the same way you deal in normal natural gas appliances.
So I can comment generally on hydrogen safety. So first of all, hydrogen is a fuel, and like gasoline, if you use it the wrong way, you can get an explosion or a fire out of it. No question about it. But hydrogen has some natural characteristics. First of all, is extremely light, as Ganesh said. So light, in fact, that it can travel up at 45 miles an hour. So it's like 60 feet per second. So if you say 1,001, that little hydrogen molecule has already gone up like a 6-story building in height, and it naturally tries to escape. So the main safety things are to first of all, using compatible materials that are not susceptible to things that are degraded by the hydrogen, and not having it in a confined space where it can be mixed with oxygen. So you have to look at ventilation. You have to look at reducing any ignition source. So there's a whole variety of safety issues. Basically, hydrogen does not emanate a lot of heat because there's no carbon in it. So actually, you put your hand within 2 or 3 inches of the flame front. So there's several characteristics. One of the main safety things we do is setback distances. So you look at, what a hydrogen cloud might look like, and you set back your equipment based on those setback distances. And in the old days, it was pretty rough calculations. So you had large setback distances. But as we get smarter and we use more finite element analysis and things like that with the national labs, those safety distances have shrunk considerably, like almost 50%, as we get more and more comfortable and familiar with its characteristics. So, you could talk for about 20 hours on safety, but that's kind of the top level stuff.
Thank you both. Last question. In your opinion, is there anything regular citizens throughout the US can or should do to help get hydrogen power to become more widespread?
Yeah, I can say right now we need cheap electricity from that's what's going to make it happen. So, here in Hawaii, the best energy source potential we have is geothermal. And I say that because it's 24/7 power, and it's good capital utilization, whereas solar is only good for 4 or 5 hours a day, and the wind is probably about maybe 5 or 6 hours a day, but it doesn't blow all the time. So really what you want to do is have a source of power that's steady state and operates all the time. And we're sitting on a ton of geothermal right now. In fact, you don't have to have, if you drill deep enough, you're going to hit something hot. So that's my hobby horse, is I think we need to be getting after it and have a geothermal resource on each island so that you don't have to worry about inter-island transport of hydrogen. Top level.
Yeah, we try to start on time and end on time. And so what we can do is we can cut those who want to get off right away can get off, and we can stay on for a couple more minutes. I want to, have some informal discussions with both Ganesh and Mitch while I have you online. So if you can stay on a little bit longer, we'll stop the formal part of the program. I want to thank both of our presenters today for really excellent comments. If you want to stay on for a few minutes, others can stay on as well too. This is really important in terms of connecting Lydia and others from the NDPTC with both Oceanit and Mitch's group as well too. So with that, thank you both very much, and a virtual applause. Right?
Thank you for the opportunity.
Yeah, thanks, everyone.
Yeah.